You know the phrase, April showers brings May flowers. According to a local meteorologist, the mean rainfall in a certain month, in a certain area in the month of April is 3.43 inches with a standard deviation of 0.13 inches. What percent of April's have between 3.27 and 3.54 inches of rainfall? Okay, so we can do the distribution. It's always good to draw a picture of the distribution. Now, okay, I'm going to assume this is a normal distribution. And actually, they should say in this problem that it's normally distributed. However, I mean, that's the only type of problem. That's the only distribution we've been working with in this section, so it better be normally distributed. The mean is 3.43, and standard deviation is 0.13. And then they said, what percent of April's rain is between 3.27 and 3.53. So that's another way of saying, you know, what proportion of April's. So how, you know, how basically what percentage of April's have this quality that their rainfall is between 3.27 and 3.54. So when they ask for either the proportion or the probability of selecting a randomly selected one in the range, then we find the area under the curve. So it's between 3.27. So it looks like this is to the left, and then this is to the right. And then we just have to find the area under the curve between those two. So to find that area, if you have a TI-84 calculator, you could do normal CDF, that you go second bars, hit the second button, and then hit bars to get the distribution, and then you do normal CDF function, and then you put the lower bound, and I read it from left to right, that's where the shading starts, is 3.27. Rate of shading stops, 3.54, and then the mean and standard deviation, which is a 3.43 and 0.13, and then that will give you your answer. That'll give you the area under that curve. Okay, or you could use class calc, which I'm going to do right now. I'm going to use class calc. So I'm going to do stats and then DIST, standing for distribution, and then go normal distribution. And then we input that mean and standard deviation, 3.43 and 0.13. And then now I click on CDF, and then when they say they want between that, then I know how I put the smaller number is just like the number line. The smaller number is to the left, and then the bigger number is on the right. And then I just put an X in between them, and I just make the X's. Now, which way should I make? Now I'm going to do two inequality symbols. So which way should I make those inequality symbols? Well, we have the, I mean, if the X weren't here, we would have to, and there was just between the two numbers, it would have to say the alligator's mouth would be facing toward the 3.54. So we just put two of those in between there, and then that's what this looks like when they say, that's what we want. So we're referring to the probability that the random variable is between 3.27 and 3.54. So now we just put it into the class calculator exactly as we see it. So the alligator's mouths are both facing to the right, just like we have here. And then I just put input the 3.27 and the 3.54. And then there's my answer, 0.69 2, and then they didn't tell us how many decimal places, I think. Did they? It's probably a good habit to just put at least 4 decimal places accuracy, 0.692, I guess we'll say 1, 0.6921. Let me just double check that was actually, yep, that's what they wanted. Okay, and then what is the probability that an April has less than 3.37 inches of rainfall? So we're gonna do it, we should be shading a different area out of the curve. So when they say probably the April has less than, so the variable, the X, is less than or smaller than the 3.37. That's what we're trying to find here. Probably the value is smaller than 3.37. And if you were doing this on your TI-84, you could do, first we would draw the picture. So 3.37, that's a little bit over here to the left of the mean, and it's smaller than 3.43. And then the probability that's less than, so the numbers that are less than 2.37 are to the left here. So the shading starts at positive infinity here. Sorry, negative infinity. Right, because you're getting smaller and smaller and smaller, and then you finally get to negative, and they get bigger and bigger than negative, so negative infinity. So you could put like negative 1E99. That's a really, really large number, but even negative 100,000 might work. Probably will work just fine. So that would be your lower bound, like negative 1E99. And your upper bound would be where the shading stops, is the 3.37. Remember when you're inputting the lower, this is the lower bound. And upper bound, the lower bound should always be a smaller value than the upper bound. And very large negative numbers are actually very small, smaller than small negative numbers. And certainly smaller negative numbers are smaller than positive numbers. Okay, and then they just put the mean and standard deviation. And that's how I would do this. I'd find this probability on my, if I was using TI-84 calculator. I'm going to use the class calc as well. So I'm going to clear out this. So just get back to CDF. And then how I see it, it's X. The alligator's mouth is facing away from the X. And it's facing toward the number 3.37. So here, the alligator's mouth is facing away from the X, just like you see here. So I think 3.37 needs to be here. And so that is right. That's the way we want it to put. If you accidentally put it on this side, you would notice that the alligator's mouth would not be facing toward the 3.37. So you'd know that it's not right. That's the wrong place to put it. Okay, so then to 4 decimal places, we go 0.32222. Okay, the 5th decimal place is 0, so it's less than 5. We would not add anything but 0.3222. And there we go. 3 2s. That would be our answer. Then up next, they ask, what is the probability that April has more than 3.5 3 inches of rain? So it's the same distribution, same mean, same standard deviation. So we're going to leave the same, it's the same setup here. And let's write this out algebraically. The April, or the value X, has more than, so is bigger than 3.53. So 3.53 is to the right of the mean. And the value is bigger. We're trying to find the probability of it being bigger than 3.53. So that we shade and find the area under the curve where the numbers on the x-axis are bigger than 5.3. And so when we go to the right, their numbers get bigger. So that's our area. Now the lower bound is where the shading, I read it from left to right to find the lower bound and upper bound. So the where the shading starts is 3.353. So that's what we want here. And then where the shading ends, it's a tricky question because it's actually ending at positive infinity over here. Because we're going to larger and larger positive numbers. And then, so we can't put positive infinity in, but we put positive 1 times e99, or you could put like 100,000 and it will also work. Positive 100,000. So I put 1 e99. And that's what I would just press, I put all that stuff into the calculator and I just press enter if I were using a TI-84 calculator to get my answer. Or you can go to class calc, and I'll do it on here, and clear that out, press, I have the same median standard deviation. It's all the same for all these problems. They haven't been changing that. And now I notice the X is greater than 3.53. So this alligator's mouth needs to be pointing away from this 3.53. So if I put it right here where the positive infinity is, then the alligator's mouth will be pointing toward the 3.53. So that's the wrong spot. So if I put it here where the negative infinity is, then the alligator's mouth is away, would be pointing away from the 3.53, which is what we want. So we want this 3.53. And then there's our answer, 0.2208. But actually, in the fifth set, some places is 7, so we round up, so 0.2209. I believe that's what we just said. And all right, and there we go. That's our answer. All right, please let me know if you have any more questions. Thanks for watching. Bye.